Hello YouTube viewers, welcome to my show Science Thursday. In today's episode, we're going to talk about nanogenerators. So let's dive right into it. Well, first you have to understand our need for power is growing, and it's not only growing like as in like 2 to 4 to 8, it's exponential. Basically, it's like 2 to 20 to 200. It's ludicrously going up, and not to mention, even this year, we will consume more power than past decades, basically, so to say. So, our power consumption is going up. Now, if you go early on, as in like the introduction of electricity, that time every load that was put onto the grid was very big loads, basically, your washing machine, your refrigerators, air conditioner, things of that nature, basically, things that were big, so to say, to the grid. However, in recent time, basically as early as 2005 and to 2010, we started to create a new category of small devices. Now, why does that matter? Think of it this way: your mobile phone needs 10 watts to run. So let's say 10 watt per day. That's not much. Here's the deal: how many mobile phones are there? You are talking about a million to upwards of 2 to 3 billion mobile phone on this planet. 2 to 3 billion multiplied by 1 is a lot, multiplied by a 10, that's ludicrously a lot. So you get the idea. Like, we started to create something different. Basically, these sort of devices don't consume too much power, but enough of them exist that it is a serious drain on the electrical grid structure. So we need some way to power them. On top of that, our world is getting more complicated. We need more and more sensors to make things run longer, support us much more better, and become more energy efficient in doing so. So our need for power is unmatched, so to say. So we need power. There is no two way around it. So what about these small devices? Many of you may think, hey, these small devices are like quote unquote luxury. That is not so anymore, because at this point in time, you must be familiar with Internet of Things. Your mobile phone is an Internet of Things, and soon you may have a refrigerator, washing machine, microwave. These things will also be connected to Internet. And as of now, as I'm me talking to you, there are many industrial equipments that are connected to Internet. Now you might be like, why the hell that is happening? Well, simply think of it this way: these are what we call smart sensors. These sensors will collect the data. Let's say there is a cement plant, it has hundreds of motors, and all those motors are like big bulky investments. Those motors are not something that you buy. If something breaks, you have to repair it. Those are that expensive. So you have something like that, and there is a sensor on top of it, and it can monitor multiple things. So it will be like, hey dude, I think my bearings is degreased. Basically it needs greasing, otherwise I'm gonna break out. So it yells before it reaches a point where it's like, dude, because of running without the grease, it destroyed itself before that happens. So many industries employ this to save money, to become more efficient, to become more safer, because less thing randomly blowing up is a very good thing for safety. So this is becoming very important for our industrial sector, and you can understand the importance of industry. I don't think I have to explain that part. So that is one crucial part. All these sensors, none of them consume like gigawatt of power or kilowatts of power. They are minuscule power consumption, but they do consume power. So that is one thing. Then we come to the farming aspect. You need food. You need food to survive. So food industry is also utilizing a lot of smart farming equipments. Those equipments mostly consist of smart sensors. These sensors are doing simple measurements like soil temperature measurement, air temperature measurement, soil humidity, air humidity, pH level, things of this nature. Basically hundreds of data points is trying to collect, and more of these sensors you have in your basically farm, the better your data analysis will become, the higher your accuracy of tools become, the better your profits become, and cheaper food you will get. Otherwise your food prices will go do. India recently suffered through a very drastic drought on onions, so to say. So our onion prices literally started to make us cry, so to say, without even cutting them. So happens like food is important. Making sensors that do that efficiently, cheaply is, well, is our best interest of our stomach. So to get this idea, we need it. Then we come to health monitoring. Now I'm pretty sure I don't have to explain that, because after 2010 I'm reasonably sure 100% of you either have used a Fitbit kind of device or know at least 10 people to 100 people who are using it right now. So it is a very big deal. So how do we power them right now? Well, we use the battery, but side effect, battery sucks at this point in time. There is no two way around it. Batteries are just bad for this. Now, why is that? Well, chemistry has this simple rule around things, is basically the bigger is better. So if somebody gives you, let's say, two mobile phones, two identical mobile phones, the best way you can make them, and one has 25 milliampere hour battery, basically 2500, and then you have bigger one that is 5000. The 5000 will outlast the 2500 one very easy. Like after 2 years of daily use, regular use, or even simulated use, you will find the bigger cell will have much more usable capacity left compared to a smaller cell. The smaller the cell, the worse this gets. Now think about your smart sensors, think about the battery size in your basically pacemaker, think about the battery size in your hearing aid. These things are small, so they don't last very long. Now you might be like, why don't we make them efficient enough and use primary cells, basically use and throw kind of cells, like a lithium cell that is used in your motherboard, and many remotes nowadays use that. Even my watch, this has 10-year battery life, Casio, that also has like CR2025. They also don't last very long. Like your basically pacemaker is something that if somebody puts in you, you don't ever want to find it out like, hey dude, it ran out of charge. You never want to find that. You never want to be in that position. On top of that, pacemaker is not that that used. However, hearing aids, many children get them. Like imagine having being as a child and be like, yeah, randomly I'm not able to hear. Why? Because my battery died. So you can understand that's a very serious anxiety that parents has to deal of, and as a child grow up, they have to deal with, hey, this is something that I have to maintain. This is something, if it's subcutaneous, basically put inside the skin, they have to pull it out and replace the battery or charge it wirelessly or do whatever they can do with this. So you can understand, not only it makes it expensive, it also makes it dangerous. So it is something that we have to solve. It's not no, it is something we have to damn solve it. So that's the whole reality. Our biomedical, and as our technology improves, we can control much more things. Basically, when I was a kid in school, basically cancer simply meant death. Now that's not so, because we can detect it earlier, we can analyze it earlier, and our medication is far more better. So I have family members who have suffered through cancer, and they're like, yeah, okay, yeah, it was a thing that we had to deal with. Cancer went from a death sentence to that in my lifetime. So how imagine smart drugs that can directly be placed into your body. Again, those will help you drastically. However, they need power to do so. That is why we are talking about nanogenerators. So we come to nanogenerator aspect. Now, nanogenerator works on a different principle compared to all other magnetism system. Basically, it works on static electricity. And I'm reasonably sure this video you must be watching in winter. You must have got shocked by static electricity at least few times by now. I'm pretty sure of that, at least in your lifetime. So we know static electricity, we are experienced with it. Somebody came up with the idea, why not use that static electricity into useful electricity? Can we do that? Short answer, yes. But critical component here is that electricity is directly proportional to the surface area. The bigger the surface area, the more oomph you get. As simple as that. The bigger, the better. So how do you make something bigger? You make it smaller. Now you're like, wait a minute. How the heck you can make something smaller and mind increasing the surface area? Think of it this way. You have lungs. Lungs have capacity. Now how the heck that lung is doing that? Lung is literally, you have blood that is sucking oxygen from the atmosphere directly. How the heck that's happening? That is happening on ovule level. Now ovules are small sac kind of structure in your lungs, and if you open them, like, okay, this sphere has this kind of surface here, let's open that, and you start to place out all the ovules that your lungs have. This puppy has around one tennis court kind of surface area, so it's huge. So same way, now ovules are huge things, like you can see them under a microscope. Imagine you made them smaller than basically a nanometer kind of scale. It's huge. Like at that point you will have like surface area equivalent of a country, so to say. So that is why we want to make it nano. That is the whole point of going to this nano scale, so we can have small physical surface, basically what you can touch, but in a chemical level, on a molecular level, it would be like hundreds of kilometers across, so to say. So that's the whole point of going to nanoscale. Now be mindful, it does create AC electricity. It is not DC, it's not plus or minus, it's like alternating currents up and down, and it does go very high voltage. So you have to have a rectifier on it to work, so to say. So it does create electricity. Now the main reason why so many people are so excited about it, it works on low frequency. Basically everything you can use to make electricity. If you are familiar with Chernobyl, you must see people doing like this to run a basically small generator that can power LEDs. Now things work, it's awesome, everything is fine, but you have to understand, you are not directly powering it through this motion. What you are doing is you are transferring this motion into a gear system. That gear train is basically increasing your RPM, because if you have slow RPM, it will simply not work. You need very high RPMs. Same goes with every generator we have. It has to be above certain RPM. It cannot work on slow RPMs. Basically you can have a generator and you're slowly turning it, it will not do like, it won't be like, okay, instead of creating let's say 110 volt, it will create 10 volt. It will simply not do anything unless it reaches a critical threshold. These puppies have very low threshold. Basically, instead of having a mobile charger that are going like this, you can be simply walking and it can charge away from that. It can charge from low frequency. That is the golden point about this. However, this is one critical thing. Even though it has ludicrously high voltage and people are showing multiple LEDs, those are just fluctuating. And please do understand that the moment if anybody nobody says about watts, the power output is very low. The power output, all these systems are minuscule. Do not think you can oh, I'm gonna cover my roof and I'm gonna be gonna run my home through wind electricity. It will simply not work. You will be better off by using solar panels, so to say. So in terms of power output, it is very low. Be mindful of that. So don't expect your mobile phone to be rescued by this anytime. However, even in that kind of scenario where it does not have the oomph, it does have more than enough. And or not to mention, our nanotechnology and other fields have improved so much that your basically watch can run on nanowatts. Your smart sensor can be made to run very little amounts of electricity. And again, LEDs do work on this kind of equipment, so you can get the idea. We are very efficient with the energies, even if we can create a very small amount of it. So what does that allow us? That allows us self-powered sensor. Think of this way: you have railways have tracks have fish plate, basically, where the two metals are connected. You want to put a strain gauge on them, so you can be absolutely sure when train is driving on it, it's safe. Now, can we build strain gauge cheap enough? Absolutely. Can we build sensor that can transmit that data to, let's say, a locomotive, and it's when a locomotive drives on top of it, it's like, dude, I'm good or I'm not good? Super easy. Then why don't we do it? Simply because even if we can mass produce it, which will reduce the cost of per unit to minuscule, like few cents or something like that, how the heck you gonna power it? Because if you use a primary cell, which is put and forget, you have to remember that after 5 years or 1 year or 2 years or something like that. Basically, you have to remember to replace them. And if you use rechargeable, then the problem, because how the heck you gonna charge it? On top of that, let's say somehow you put solar panels or something like that, that allows you to charge it without any issue, or some mechanical system where a train running on top of it, so you can mechanically reliably get electricity out of it. The cells itself will wear out in 1 year or 2 years. If heavy used, it will wear out very quickly. So what the hell you do? You utilize these puppies. These puppy can remove that headache. It's like, this is mass produced thing. It has its own generator. It will send out a signal when it detects an issue. That's it. You don't have to do anything else. So that will drastically change our infrastructure on which our life depends. So imagine this, hundreds and millions of them put into a bridge where you can literally check every single nut bolt. Before anything bad happens, you'll be like, dude, this stud is YOLOing around too much. Let's fix this issue. Before a train is derails, we'll be like, bro, this fish plate needs some attention. Flyovers, you can maintain it. Dude, it's starting to crack, please repair it or shut it down or decommission it. So those are very important things. Mind-boggling. It will change your life without you ever noticing it. Then we come to battery for smaller trucks. Our small trucks have become efficient enough because this is an old technology. This is released in 1980. The Casio, basically, I forgot what it, W8 or something like that is this, which has 10-year lifespan on a single cell. Now imagine it was powered by a generator. It will simply be as long as you keep using it. It will last forever, basically, so to say. And it will not have moving parts. So do not say, oh, we have that. Moving parts are not long lasting. This does not have a moving part. So batteries for smaller trucks, your Fitbits, those things will improve drastically. Imagine a smartwatch that you don't have to charge every day. So amazing things we can do that. And then biomedical application. Imagine giving your child a subcutaneous basically hearing aid if it needs it, and forget about it. Yeah, it's there, don't worry about it. Unless it breaks or something bad happens, you don't have to worry about it. That will drastically improve people's life who are dependent on biomedical devices. And on top of that, we can have even better biomedical device created because now we have the energy source to power it. Now be mindful, these will be microwatt to nanowatt kind of structures, because if it's bigger than that, you will know. If somebody puts a diaphragm pump on your lungs and you're every breath will you will start to notice something. Think of it this way: if you have driven any cycle, try connecting a motor to it, just a few watt generator, try to connecting that. You will notice that instantaneously. Energy cannot be created nor destroyed. So as long as it's very small, you will not notice it. But if it's a big load, let's say your pacemaker is drawing 1 or 2 watts regularly, you will know it. So you have to power it through muscle, so you can do it. If you power it out of diaphragm, you will always doing like this. So be mindful with the power requirement, but it can change drastically. It can allow you to put wind mats where wind speed is not too high for a proper wind turbine, but it's enough that you can have this kind of structure and charge your mobile phone. So small things can be done very drastically. It can take care of the loads of small loads, but do not expect keyboard is gonna power your laptop. That's not gonna happen, because that means you have to power 10-20 watts out of these puppies. These are not meant for that. Try that, please try that. Please try to extract 10 watts of power out of these. Not your hands, on your fingers. It will hurt a lot. So you get the idea. It can change the world, it can make world better, but do not magically expect this to replace everything, because even the I'm saying physicist who deal with this is like, yeah, 1 square kilometer of area of sea, if we put on top of that, we're gonna get 1 megawatt. 1 square kilometer, 1 megawatt. No, just no, nobody will allow you to do that. Block off 1 kilometer of sea just so you can get 1 megawatt. That's too low. So this was my presentation on nano generators. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment. Please leave a comment, because I reply to all of them, or try to. Subscribe, press the bell icon if you're free, and as always, thanks for watching.